So we have seen this, right? Binding energy curve Z, binding energy per nucleon. The curve looks like that, right? So all these uranium kind of atoms will fall here. Iron, barium, all other stable elements will fall here, and all basic elements like helium, lithium, nitrogen, carbon, nitrogen, all those things will come in this sector. So now, what was our first property? First or second property lo em chusamante, the volume is proportional to atomic number అని చూసాం. అంటే ఏంటి, whatever may be the number of nucleons, the volume increases proportionally. That means when you add one more atom, it keeps equal distance from its neighbors. But ఇప్పటి వరకు చెప్పుకుంది ఏంటి, as of now what we are discussing is the number of interactions will be n into n minus 1 by 2. Number of new interactions. So only look conflicting. Whenever a new nucleon enters into picture, it keeps equal distance with all its neighbors, as if its previous entry makes a distance. సో దాని ముందు సపోజ్ ఒక 10th న్యూక్లియన్ ఎంటర్ అయినప్పుడు ఎంత గ్యాప్ మెయింటైన్ చేస్తుందో, 11th, 15th, 30th న్యూక్లియన్ ఎంటర్ అయినప్పుడు కూడా అంతే గ్యాప్ మెయింటైన్ చేస్తుంది. దట్ ఈస్ వై వాల్యూమ్ ఈస్ ఇంక్రీజింగ్ ప్రపోర్షనల్. ఇక్కడ స్టేట్మెంట్ అంటే the number of interactions are increasing exponential, not exponential, as n square. So and all these are repelling interactions. So if the repelling interactions increase more and more, the separation should increase, right? So what happens actually is, we are talking about this region where binding energy per nucleon remains constant. Binding energy per nucleon is constant. What is that value? It is around 8. Page 395. Binding energy per nucleon is constant and value is around 8. 8 అంటే ఏంటి? Oxygen. So it starts with oxygen. So whatever binding energy oxygen maintains per nucleon is almost same for rest of the elements. And this uranium and all will make a deviation, little deviation. So that is why fission energy is very small compared to fusion energy. This gap is very large compared to this. Okay, so at this level around 8, binding energy per nucleon is constant. So if you add one more nucleon, the energy required, additional energy required is constant, 8 units. If you add one more after 8, 9, 10, 12, 15, 30, 50, up to that level, binding energy per nucleon is constant. I mean, if you just supply 8 MeV, you are able to fix that nucleon. I mean, if you remove that 8 MeV, you are able to fix that nucleon. length of the nucleus. That means what? So this number of interactions is now proportional to n. It should be a number of nucleons. So we call it as a into a minus 1 by 2, whatever. If it is n, okay, n or a, whatever. So if a new particle enters into picture, actual number of interactions should be n into n minus 1 by 2 or a into a minus 1 by 2, whatever that new particle count. But practically, that number is now proportional to n. Nothing beyond that. Because of the shielding produced by neutrons. All these interactions we are talking about are between the protons only. Is it? The main effect or main repulsion, the main requirement for binding comes from the repulsive interactions between protons. Neutrons act as a buffer. Okay, so the number of interactions now reduces to a instead of a square because of that shielding effect produced by neutrons. So that's why here this number is almost constant. And in that region only this condition is valid. Volume is proportional to A. Here there is a drastic change. Here there may be some change. Okay. So on average we are considering the nucleon binding energy to be 8 MeV per nucleon. Okay. So that is the most crucial point that we need to understand in this level. Okay. So next one, what is that? What is the next property? Angular momentum. So angular momentum, for electron we have two types of angular momentum. One is orbital angular momentum and another is spin angular momentum. One comes by orbital motion, another by spin for electron. And for nucleon, how many possibilities are there? How many degrees of freedom at least? So at most they may have spin angular momentum only. I mean they cannot have orbital angular momentum. So for nucleon you have only spin angular momentum. Is it? So you cannot decide that part, either orbital motion or spin motion, because dimensions of nucleus are very small. You cannot identify this spin part or orbital part. So ultimately we decide angular momentum of nucleus is I. So it will have components from both orbital and spin motions. And that part is fixed. Okay. So since it is a fermion, nucleons are fermions. So they will have half integer spin. Half h bar I is the angular momentum. Okay. I is equal to that is the angular momentum eigenvalues. This is the total angular momentum, this is the vector. That takes half integer values. So if you have even number of protons, even number of neutrons, okay. So it takes integer value if the particles are even in number, and in total it becomes 0 if the particles are so what happens? So in total, if odd proton gives you half integer, and odd neutron, that also gives you a half integer, and total of these two will be an integer. So if you have odd number of protons and odd number of neutrons, each will get you half integer, and total angular momentum of nucleus will be an integer. And if both are even in number, this total will become 0. Individually, if proton count is even number and neutron count is even number, net angular momentum becomes 0. So there we need to consider what? Magnetic quantum numbers. So what is that magnetic quantum number? So if I is your quantum number, magnetic quantum number is, it takes values from minus I to plus I with the integer step size. So each nucleon will take magnetic quantum number values from minus I to plus I. Let's say if it is in a second orbit, corresponding magnetic quantum numbers will be minus 2, minus 1, 0, plus 1 and plus 2. So net angular momentum 0. Is that the case? So okay. So this part we will see exactly when we go through that shell model of the nucleus. So what exactly happens when you have even number of nucleons or odd number of nucleons? What is the total angular momentum? That part we will discuss at that level. But as of now, if you have even number of protons and both even number of neutrons, the net angular momentum will be 0. Okay, and if you have odd, individually you get half integers and net will be an integer. Okay, so that's about angular momentum, and next comes the most important parity. Half integer.
Half integer. అంటే
1 plus half, 3 by 2.
Half.
Okay. So next one, the most important property that decides the fate of entire nuclear physics is the parity. So parity deals with the symmetry, it deals with inversion symmetry. The symmetry laws are the fundamental rules that decide the properties of these nuclear reactions, and that is the most essential aspect that gave a clue to understand the nuclear interactions. Okay, without that we cannot predict the future of certain nuclear reactions. Why certain reactions occur in a certain fashion is purely decided by this symmetry interactions. So the fundamental is one such symmetry rules is the parity symmetry. Parity deals with spatial inversion symmetry. So when you take any nuclear particle or entire nucleus, if you perform spatial inversion operation, what is inversion? You have to transform x to minus x, y to minus y, and z to minus z. So keep 3 mirrors along x, y, z directions. What is the final configuration? Does it change? If it changes, it makes it is called negative parity, minus 1. If it does not change, you call it as positive parity, plus 1. And it is ultimately controlled by P is equal to minus 1 power I. The total angular momentum of the nucleus. If it is odd, you will get odd parity. That means sign changes upon inversion. If it is even, you get even parity. Sign does not change. So we'll see a simple example. Especially that parity is a essential parameter even in mechanics, where you come across normal vectors and pseudo vectors. Like angular momentum is a pseudo vector. Ordinary momentum compared to ordinary momentum, angular momentum is a pseudo vector, and this parity operation is the chip control parameter or identification parameter to distinguish normal vectors from pseudo vectors. Okay, we'll say a simple case. What happens if I apply this spatial inversion operation on the angular momentum state? Okay, so what is the direction of angular momentum? Let's say a particle is moving in anti-clockwise direction. What is the direction of angular momentum? So it is given by right hand thumb rule. If your curl of fingers gives you the direction of rotation, thumb gives you the direction of vector. You can even take left hand thumb rule. That is a simple convention. Most often people follow right hand thumb rule. Okay, once you choose one convention, you have to follow it till the end. Okay, I am choosing that right hand convention. So if your curl of fingers represent the direction of motion, thumb gives you the direction of vector. Okay, so this is the direction of vector and this is the direction of motion. Let's say this is an xy plane. The particle is moving on an xy plane. I am considering the z axis. Above the plane. So now I'm applying spatial inversion operation. So I'm keeping 3 mirrors along x, y and z directions. And I want to see what is the final configuration and what is the direction of angular momentum in the final configuration. Okay. So now what shall I do? I have to keep a mirror along x direction. So on the forefront of this board, I am keeping a mirror. So how does it look like in the mirror? In the mirror, it looks like this. If I say in the mirror, whatever inner portions will be inner portions in the mirror also. This outer portion will look nearer to me. So that is the final stage for X mirror. I am keeping X mirror. That is the final configuration. What is the direction of angular momentum?
Clockwise.
Angular momentum downwards. Now I keep Y mirror. So I keep a mirror here. So what will I see in the mirror? So this portion will be seen here. The mirror is here, Y direction. Now what is the direction of angular momentum? Now I keep Z mirror above the plane. So what is the result? Z mirror. It looks the same. So angular momentum does not change sign upon spatial inversion, whereas ordinary momentum or any vector, let's say displacement, velocity, acceleration, any vector, take any vector, let's say the person is traveling along z direction, vector. So apply X mirror, it will be still traveling upwards. After X mirror, this is the result. Apply Y mirror. Apply Z mirror. So if the person walks towards the mirror, it will be seen as if walking towards the observer. So finally, direction changes. Right? So that is the basic difference between normal vectors and pseudo vectors. Pseudo vectors does not change sign. Why the name pseudo vector, by the way? So pseudo vector name better and యాంగులర్ మొమెంటం అంటే ఏంటి? రొటేషనల్ యాంగులర్ మొమెంటం. ఓకే, so mass multiplied by or moment of inertia multiplied by rotational velocity, L is equal to I omega. Okay, so it is the property that keeps an object in circular motion. If angular momentum is 0, object will not be in circular motion. If angular momentum has a finite value, object will be in circular motion. So what is the primary requirement for an object to be in circular motion? So object in circular motion తీసుకురావాలంటే ఏం చేయాలి? So what is the primary requirement to bring an object into circular motion? Okay, fix its center. And some force should be acting towards it. Yes, there should be a perpendicular force acting always towards a fixed point. Let's say a person is traveling like this and somebody is pulling towards a point perpendicular to direction of motion. What happens? The direction of motion changes. So this is the original direction. There will be tilt. At this point also there is a perpendicular force acting towards the same point. Okay, then the direction changes. So we require two driving forces, one to keep the linear motion, another to pull back towards a fixed point. So only when two mutually perpendicular forces act on a body, then and only then object comes into circular motion. Okay, so now we need to represent this entire activity as a single vector. So akkada jarugutuna mottham activity ante enti, at every point there must be a perpendicular force towards a point. Ee mottham activity ni nenu oka single vector ga represent cheyali. What should be the direction of that vector? What should be the direction of that vector? Let's say I am traveling in this direction. I can say my displacement is towards east or towards north. I can fix the direction for that. For my velocity or for my acceleration, I can fix a direction. How to fix a direction for this?
Identity perpendicular.
How to fix a single direction for this entire activity of keeping an object in circular motion? The only distinction I can make is at most 10 rotations per second or 20 rotations per second. That angular velocity I can vary. Right? So based on that I can vary the magnitude of the vector, but what should be the direction of the vector? For magnitude, okay, I can decide if it is 20 rotations per second, I keep 20 units of length. If it is 10 rotations per second, I keep 10 units of length. What is the direction?
Linear path.
Which way? So he cannot lie on the plane because the entire activity, I mean the activity covers the entire plane. So you have to go above or below the plane for your vector. So that's why there are two conventions coming into picture. So the formula is we need a cross product. Radial vector is a vector connecting the object from the center. This is the radial vector, and this is the linear momentum of the object, r and t. Right? So now we have to take a cross product of these two vectors. Okay, so the resultant vector is perpendicular to the plane containing these two vectors. Valid. But which direction? There will have two possibilities. Either right hand thumb rule or left hand thumb rule. Most convention is right hand thumb rule. So, starting from first vector to second vector, the curl of fingers represent the direction of motion or the direction of angle or the direction of least possible angle from first vector to second vector should be the direction of your curl of fingers. So what is the first vector? This is R and this is P. What is the direction of journey from R to P? Which way should I take? Is it this or this? I mean, as per the definition, it should be smallest. So I have to take this. But then, if the object is in anti-clockwise motion, my right hand thumb rule says the vector must be upwards. The basic definition for cross product is the curl of fingers must be starting from first vector to second vector. So I have to start from R and travel towards P. Which direction? Is it clockwise or anti-clockwise? Decide that. So the fundamental rule is when you calculate angle between two vectors, the vectors must be connected head to head or tail to tail. Both vectors must be connected head to head or tail to tail. Here the tail of one vector is connected with head of another vector. So we cannot measure angle between two such vectors. Fundamental rule. So there we use the flexibility of definition of vectors. As long as you keep the direction and magnitude of vectors, you can shift it to anywhere. As long as the direction and magnitude does not change, you can shift the vector to anywhere. So I'll shift my vector over there, and then once I get a head to head connection or tail to tail connection, then I'll see the direction of motion. It is anti-clockwise. So for anti-clockwise motion, the vector will be upwards. Okay. So that is about angular momentum. So you cannot give any fixed direction for the activity of rotational motion, because the entire activity covers the entire plane. There is no fixed direction. So it is only our convention. I may take left hand thumb rule or right hand thumb rule. So based on my convention, the direction of vector changes. That's why they are called pseudo vectors. And most important property of pseudo vectors is upon parity operations, upon spatial inversion, pseudo vector does not change sign. Whereas any ordinary vector changes sign upon spatial inversion. So that is a fundamental test to identify or to distinguish ordinary vectors and pseudo vectors. So these angular momentum vectors are pseudo vectors, and if you keep the angular momentum intact, I mean if it is an integer value, this parity operation gives you +1. If it is a half integer, what happens? If it is an even number, integer value, if it is an odd number, half integer value. So that's how parity controls. I mean certain reactions occur, I mean this is also a conservation parameter, that parity should remain conserved during any nuclear reaction. So when you are breaking a given nucleus into two equal pieces, you have to ensure either integer pieces or half integer pieces based on your original nucleus. So that parity should be conserved during any nuclear reaction. So that is why it is also a most important parameter. Okay. So rest of the things we'll see in the next session.